respect students, this is 6th session. I'm going to revise what we did in the previous session. Alright, I said this is magical hexagon, wonderful hexagon with a crown. Why? This looks like a head and this table is like a crown on the head. That's why I called it as magical hexagon with crown. Okay, few things I've already put here so that I don't take more time in drawing it. Okay, here is the hexagon, right? We start from the top left, cos theta, sin theta and tan theta. Reciprocal of cos, sec, yeah, you can call it inverse. Reciprocal of this sine, that is cosec. Reciprocal of tan, that is cot. Alright, now this clockwise that I have put in these three triangles, that gives you identities. This cos, sec, tan, cos, sin, tan, sec, cosec and cot, which is surrounding the hexagon at its 6 corners, will give you trigonometric relationship, interrelationship. Alright, all interrelationships they will give. Okay, then what else? Yes, this gives you trigonometric ratios of special angles, and this 3 parallel lines, it gives you trigonometric ratios of complementary angles. Alright, and the definition you get from here, ka, so, tova, cos का रेसिप्रोकल है, sec का रेसिप्रोकल है, cosec और tan का रेसिप्रोकल है, cot. This is cosec and this is sec. Okay, that's it. Now, first I'll put these values. Okay, well, first value is of cos and second value is of sine. You have to think of the pairs. The pairs are 1, 0, root 3 by 2 and half, and yes, 1 upon root 2 and 1 upon root 2. In this pair, they are twins like. Okay, they look similar. Anyway, 0, 1, 0, 30, there is 3 here, so that is root 3 by 2 and 1 upon 2, uske saath jodi. 45 is 1 over root 2 and this is also 1 over root 2. Then the 60 is just like 30 but reverse. Half comes first and root 3 by 2 comes next. 0 is like 90 but reverse. Here 1 0 hai, this is 0 1. Now here, okay, this is cos, this is sine and this is tan. What is tan 0? Sine upon cos. Sine upon cos. 0 upon 1, that is 0. Well, sine upon cos. Now tan 30. Numerator 1 upon numerator root 3. So 1 upon root 3. Denominators cancel. Numerator upon numerator 1 upon 1, that is 1. Root 3 upon 1, numerator is root 3 upon numerator is 1. Root 3 upon 1 is root 3. 1 upon 0, that is undefined. You can say that is undefined. Correct? Alright. So that's how you got all these values. See what sir put here. Inverse. When you want sec, तो वो sec नहीं है, sec का inverse है. Like sec 45. आपको चाहिए sec 45, तो देख लीजिए ये 1 upon root 2 है लेकिन ये sec नहीं इनवर्स है, सो उसको इनवर्स कर दो तो sec 45 is root 2. या if you want cos 45, वो सीधा मिलेगा cos और 45, that is 1 over root 2. Yesterday I did put up there, but yeah, it was overwritten on the title, so I didn't put the title today here. Okay, fine. So you can find out any as you like. Okay, say suppose cot 30. So 30 is here and cot, not cot but 1 upon cot, reciprocal hai. So you get 1 upon root 3. लेकिन इसका रेसिप्रोकल करेंगे तो √3. सो 1 अपॉन कॉट इज 1 अपॉन √3. सो कॉट इज √3. इज दैट क्लियर? चलिए लेट्स फाइंड आउट tan 60. tan और 60 here they meet, you get directly, that is √3. ये रेसिप्रोकल नहीं है, ये रेसिप्रोकल में ही आपको ज्यादा ध्यान देना पड़ेगा. यू हैव टू बी केयरफुल. ऑलराइट. और यू कैन फाइंड आउट, ओके, सपोज के cosec, तो cosec इज रेसिप्रोकल ऑफ sin. व्हाट इज sin 60? √3/2. लेकिन हमें तो cosec चाहिए, तो 2 upon √3. आर यू गेटिंग मी? गुड. नाउ सी, नाउ interrelationship. Let me take definition. You know, cos is adjacent upon hypotenuse and the sec is hypotenuse upon adjacent. Sin is O for opposite upon H for hypotenuse. Then cosec is hypotenuse upon opposite. Tan is opposite upon adjacent and this cot is adjacent upon opposite. Now interrelationships. Interrelationships. Please see this interrelationships that I'm writing now. 5 are basic and that is this cross, ye diagonal, cos into sec. Cos theta into sec theta is equal to 1. Next, sin theta into cosec theta. Sin theta और दूसरे एंड पे cosec theta. Sin theta into cosec theta is equal to 1. Then tan theta into cot theta. Tan theta into cot theta is equal to 1. Alright? Understood? अभी उसी का फॉर्म, उसी को मैं यूज कर रहा हूं ना. What is sec? What is cos? 1 upon sec. What is cos theta? 1 upon sec. And what is sec theta? 1 upon cos. Sec theta is 1 upon cos. ऐसे मिलता है. cos इसका रेसिप्रोकल है, so 1 upon sec. Sec इसका रेसिप्रोकल है, so 1 upon sec and cos. Like that you get all. Tan theta 1 upon cot. Cot theta 1 upon tan. Tan theta 1 upon cot theta और cot theta 1 upon tan theta. So 1 upon tan theta. Got it? Like that. Sin theta 1 upon cosec theta. Sin theta is 1 upon cosec theta और cosec theta is 1 upon sin theta. देखा बहुत सारे इंटररिलेशनशिप. अब दूसरा वो एंटी क्लॉकवाइज. tan is sin upon cos. tan theta is sin theta upon cos theta. All right. Then cot theta. Cot theta is cos theta clockwise. Cos theta upon sin theta. Cos theta upon sin theta. कोई भी ले लो. cosec theta cot theta upon cos theta clockwise चले. cosec theta is cot theta upon cos theta. cot वो आ गया. cosec theta एंटी क्लॉकवाइज चले तो cosec theta is equal to sec theta upon tan theta. cosec theta is sec theta upon tan theta. ऐसे आपको मिलेगा. कितने मिलेगा? 1 2 3 4 5 6. 6 क्लॉकवाइज, 6 एंटी क्लॉकवाइज. सो ऐसे आपको 12 मिलेगा, है ना? ऑलराइट. और इस तरीके से आपको 5 3 और 3 6 9 मिलेगा आपको. 12 9. अब ये भी मिलेगा. एक्चुअली दे आर वन एंड द सेम चिल्ड्रन. 1 2 3 4 एंड 5. ये जो है वो बेसिक है, उसी में से सब मिलते रहते हैं. बट यू कैन गेट इट वेरी इजीली फ्रॉम हियर. एक और cot theta is equal to उसका नेबरिंग ट्रिगोनोमेट्रिक रेशियो ए बाजू और नेबरिंग ट्रिगोनोमेट्रिक रेशियो ए बाजू, दोनों का प्रोडक्ट. सो cot theta is cos theta into cosec theta. cos theta into cosec theta. उसी तरह कोई भी ले लो. सपोज साइन, ये साइन. सो साइन थीटा उसके लेफ्ट में नेबर है cos थीटा, उसके राइट में नेबर है tan थीटा, उसका प्रोडक्ट. आप मिडल का ले लोगे तो आजू बाजू का प्रोडक्ट. क्लॉकवाइज या एंटी क्लॉकवाइज चलेगा तो रेशियो। आर यू गेटिंग मी चिल्ड्रन? आई होप यू ऑल आर फॉलोइंग इट। सी कितने इंटर रिलेशनशिप है, तो सिर्फ 5, लेकिन उसी में से सब प्रोड्यूस होते हैं एंड यू कैन गेट इट फ्रॉम हियर। क्लियर टू यू? नाउ लेट्स सी इंटर रिलेशनशिप। Sorry, interrelationship we have already seen. Identities. All right, let's see the identities. तो ये रही identities. Start cos. Identities में squares है. Cos square theta plus sin square theta is equal to 1. Cos square theta plus sin square theta is equal to 1. यहां alone क्या है? 1 है ना? देखो 1 alone है. So you can start with that. 1 minus sin square. 1 minus sin square is equal to cos square theta, or 1 minus cos square that is equal to sin square theta. ऐसे भी ले सकते हैं, मिला के नहीं, एक्चुअली ये दो फॉर्म इसी में से मिलते हैं। cos square plus sin square plus 1 gives 1 minus sin square is cos square, इसको ये बाजू ले गए, and 1 minus cos square is sin square। चलिए नेक्स्ट आइडेंटिटी, ये क्लॉकवाइज 1 स्क्वायर इज 1 प्लस 10 स्क्वायर, 1 प्लस 10 स्क्वायर थीटा इज इक्वल टू sec स्क्वायर थीटा। ये बेसिक आइडेंटिटी है। ऑलराइट, नाउ इसमें अलोन है sec, मैंने राउंड कर दिया, 1 को राउंड किया, sec को राउंड किया, cosec को राउंड किया। दैट शोज इन आइडेंटिटी दे आर अलोन। देखो अकेले है, ओनली सिंगल टर्म। So now sec square minus 10 square, from here you get sec square theta जो alone है minus 10 square theta is equal to जो remaining हुआ 1, या you can start with this alone sec square theta minus 1 square, that is minus 1 is equal to 10 square theta. Once again these two are obtained from this main. And the third one, yeah, cot square plus 1 is equal to cosec square. Cot square plus 1. Okay, so you may write first cot square, then plus 1, or as you know, you can write that as 1 plus cot square theta is equal to cosec square theta. Now from here, alone is cosec, I have put circle. So cosec square minus 1, not plus 1, cosec square minus 1, cosec square theta minus 1, that is cot square theta. और जो अलोन है वो cosec स्क्वायर कर दो, cosec स्क्वायर माइनस cot स्क्वायर is remaining 1. So again this is main 1 and from there you got. So cos square theta plus sin square theta is equal to 1. 1 plus tan square is sec square and 1 plus cot square is cosec square. And from there you have different forms. Okay? चलिए. So you got that. Now what is left? Yes. Complementary. Trigonometric ratios of complement. So here definition. Here trigonometric ratios of spatial angles. Here interrelationship. Here identities. So 4 things we have extracted from this trick. Okay. Now ये parallel line की बात है. Cos and sin are complementary. So cos of 90 minus theta is equal to sin theta, and ulta sin of 90 minus theta is equal to cos theta. Cot and tan, here 3 red lines, they are parallel. Cot theta, if I write cot theta, then it is tan of 90 minus theta, it is complementary. And if I write tan theta, then it is cot of 90 minus theta. tan का कॉम्प्लीमेंट्री cot और थीटा का कॉम्प्लीमेंट्री 90 माइनस थीटा, cos का कॉम्प्लीमेंट्री sin और 90 माइनस थीटा का कॉम्प्लीमेंट्री 90. ऑलराइट, एंड द लास्ट टू cosec and sec. Cosec 90 minus theta is sec theta and sec of 90 minus theta is cosec theta. So got everything, children? I hope you understood. This you will have to practice again and again, that so that you do not forget anything. Children, 1 के लिए कितने substitution है कभी हम देखेंगे, या अभी बताता हूं. What is 1 cos square plus sin square? What is 1 Yeah, 1 is what? 1 plus tan square. Here it is. Sec square minus tan square. What is 1? Cosec square minus cot square. What is 1? Cos theta into sec theta is 1. What is 1? Sin theta into cosec theta is 1. What is 1? Tan theta into cot theta is 1. So many places you get 1. Alright? Fine. So that is, sometimes you will have to substitute for 1. For 1, we have got so many choices, so many options, and we have to make the correct choice and substitute. That is prove that type of sum that we are going to do last in this chapter. Okay? They are tough. The rest, everything is very simple. And what I said tough would become very easy if you are able to interpret this trick, this hexagon with its crown nicely. इसको बराबर interpret करेंगे, regular practice करेंगे तो क्या करना है उसमें पता चलेगा. तो very quickly and very easily you will make that tough work simpler for you. You will find it very easy. Okay, fine. So learn this nicely. All right, children. So we have taken. We are into the 5th session, children, and let's say we have taken 4 sessions, 45 minutes each at an average. So that comes to 3 hours. 3 hours of basic trigonometry we have learned. Well, I have worked hard, okay, just because so that you learn them well, so that you can memorize them easily. But it's very important that you learn it, right? A doctor can diagnose your illness and he can give you medicine in accordance to the treatment, correct? But if as a patient, if you don't take the medicines and if you don't follow the instructions given by doctor, you cannot get out of your illness. Your illness will continue. So if you want to get rid of your illness, if you want to get rid of your sickness, take those doses of medicines nicely. I hope you can understand what I'm trying to say. I'm trying to say I've spent 3 hours for teaching you basics of trigonometric ratios. 4 sessions, 4 periods. Do you understand? So now you have to take that medicine. You have to practice this regularly. Alright? I hope you will do that, and I'm sure you will do it. Okay? Now we move up to different types of sums. They are very easy, except the prove that type of sum that we are going to see the last. That also would become very easy if you learn, or if you are able to interpret that figure of hexagon with its crown, that table on top. Okay? If you interpret it nicely, you will be able to do it. Fine. So let's see. Sum type 1. Okay? To find TR means trigonometric ratios. Which are trigonometric ratios? Or how many trigonometric ratios are there? 6. Cos, sin, tan, sec, cosec and cot. So you have to find those trigonometric ratios. Or value of the expression. One expression is given. No equal to there. Only expression. Which involves those 6 trigonometric ratios. Not all 6, any of them. Okay? Or prove that. Yeah, expression is given is equal to 5, is equal to root 2, is equal to 1. So you have to prove that. Here you have to find trigonometric ratios. Here you have to find the value of expression जिसमें trigonometric ratios होते हैं. And here you have to prove that value of expression is equal to something. Actually prove that is easier than this. Here you are finding the value of expression and you don't know what will be the value. Here you are proving the value of expression is root 2. That means you know the value of expression is root 2 which you have to prove. Okay. So this is very easy. So I put tick mark over it. Alright. ये prove that से आपको डरना नहीं है. Okay. Don't be frightened of this prove that. They are very easy. Okay. Let's see. I have not written the statement. I have just drawn the figure and the information is given here. You are given right angle triangle. And you are okay. Type 1 में 1.1. 1 में 1.1. where you are given the measures of any two sides. राइट एंगल ट्राइंगल के दो साइड के मेजर्स आपको दिया है एंड यू हैव टू फाइंड all 6 या any 2 trigonometric ratios. I've taken 3 sums, so I'll find 2 here, 2 here and 2 here. The rest 4 can be found very easily. अच्छा बोलिए, now you tell me. Okay, I'll write here. Suppose this is theta. All right, this is theta and you have to find sin theta and sec theta. ये दो वैल्यू आपको ढूंढनी है. All right, say suppose this is alpha and you have to find tan alpha and cos alpha. ठीक है? Here once again this is beta and you have to find कौन से बाकी रह गए, cosec beta और cot beta. This is what you have to find. Okay, चलिए, let's start. Sin theta, cos and sec theta. What is sin theta? Opposite side. याद करो, कासोटोवा का so tova. You will need this. Sin is here. Opposite upon hypotenuse. Opposite is AB. Hypotenuse is AC. AC is known, but opposite side is not known. In short, if you have to find trigonometric ratios, you need all 3 sides because trigonometric ratios are nothing but a ratio of measures of the sides. So यहाँ तो 2 ही दिए हैं, तो third one you can find out using Pythagoras. So first work I'll do is use Pythagoras and find out AB. We know that AC square is equal to AB square plus BC square by Pythagoras. All right? Chaliye. Therefore, AC is given. AC square is 5 square. AB square is not known AB. BC is 3 square. Children, you might say this is very easy. 5 square is 25 and 3 square is 9. And 25 minus 9 is 16. है ना? 5 square is 25. 3 square is 9. So 25 और ये 9 ये बाजू आएगा minus 9. 25 minus 9 is 16. But I'm not going to do in that way. I'm getting opportunity to take difference of square. 5 square और ये minus 3 square is equal to AB square. i.e. AB square is equal to, ये left को लिखा ये right को. Now this is A square minus B square. So I'm going to use the factor A plus B. So 5 plus 3. A minus B. So 5 minus 3. 5 plus 3 is 8 into 5 minus 3 is 2. 8 2s are 16. You got same. Therefore, taking square root on both sides. Therefore, AB is equal to 4. So this is 4 centimeter. Now that you know all 3 sides, लिखो. By definition, आपको चाहिए sin theta. Sin theta is equal to opposite side AB upon hypotenuse AC, and that is equal to AB is 4 and AC is 5. So sin theta is this. And बोलिए sec theta वो इसका रेसिप्रोकल है cos का. So hypotenuse upon adjacent. What is hypotenuse? AC. And what is adjacent? Theta का adjacent. Children, if you want, you can write this. This is opposite, this is hypotenuse, and this is adjacent, so that you can pick up easily. Adjacent is BC. Now hypotenuse is 5 upon BC, that is 3. Okay. Therefore, sin theta is equal to 4 upon 5 and sec theta is equal to 5 upon 3. There you are. You have got the answer what you asked. Now say suppose you have to find cos also. So adjacent upon hypotenuse. Tan तो opposite upon adjacent. आप ले लो, बाकी के 4 भी मिल जाएंगे. Because you know measures of all 3 sides. Got it, children? 2 sides are given. है ना? So you don't know the third side, so you know you have to use Pythagoras. Okay, we know that क्या PR square is equal to PQ square plus QR square by Pythagoras. I'm writing in brief now. PR not known, PQ 40 square, sorry, PR is 41, so 41 square and QR square. Children, यहाँ थोड़ा डिफिकल्ट बन जाता यदि आप 41 स्क्वायर 41 into 41 आपको मल्टीप्लाई करना पड़ता. अभी you will realize the importance why sir is saying to take 5 square minus 3 square. यह 41 square minus 40 square, क्योंकि 41 into 41 तो आपको मल्टीप्लाई करना पड़ता. 40 स्क्वायर तो आपको आ जाएगा 4 4 are 16 and 2 0 so 1600, बट ये नहीं है मिलेगा, आपको मल्टीप्लाई करना पड़ेगा. बट टू अवॉइड दैट, therefore 41 square minus 40 square is equal to QR square, i.e. QR square is equal to 41 square minus 40 square, but I am using factor 41 plus 40 into 41 minus 40. Let me remove this now. All right, check. That is equal to 41 plus 40 is 81 into, देखो यहाँ into है, into 41 minus 40 is 1, that is 81. Therefore QR square is equal to 81. Take square root, therefore QR is equal to 9. So this is 9, children. No centimeter, no meter, nothing. So units you can see. All right. Now, by definition, आपको ढूंढना है 10 अल्फा. ये अल्फा है, ये ऑपोजिट साइड, ये तो फिक्स है हाइपोटेन्यूस, तो ये एडजेसेंट बन गया. So now, by definition, 10 alpha is equal to opposite side, opposite here, QR upon adjacent side here, PQ. That is equal to 9 upon 40. So you got it. And the next value is cos alpha. Cos alpha is equal to adjacent upon hypotenuse. You should know the definition. PQ upon PR. PQ upon PR. PQ 40. PR 41. So there you are. The values of two sides are known. The third side is not known. So we can say we know that XZ, yeah, right angle है, so this is hypotenuse. With respect to beta, this is opposite angle, and the remaining one is adjacent. Chalo, we know that hypotenuse square, that is XZ square, is equal to XY square plus YZ square. XZ not known, so equal to XY pi square plus 12 square. Now this is pi square plus 12 square already on one side, so there is no way. यहाँ आप फैक्टराइजेशन नहीं यूज कर सकते, स्क्वायर माइनस बी स्क्वायर नहीं है. सो आपको कंपल्सरी 5 स्क्वायर की वैल्यू 25 प्लस 12 स्क्वायर की वैल्यू 144 लिखनी पड़ेगी. ऑलराइट, द टोटल इज 169 and that is beautiful number, a perfect square number. So taking square root on both sides gives xz is equal to 13. So this is 13 and centimeter, so centimeter. Fine. By definition, you have to find cosec. So cosec beta, hypotenuse upon opposite. Now you should know that hypotenuse is xz and opposite is xy. So xz is 13, xy is 5. This is cosec beta, and cot beta is equal to adjacent upon opposite, adjacent yz upon opposite xy. So that is 12 upon 5. So these are the values. आपको cos ढूंढना है. Cos beta is adjacent upon hypotenuse, so 12 upon 13. Sin beta opposite upon hypotenuse, so 5 upon 13. Tan beta opposite upon adjacent, so 5 upon 12. कौन सा बाकी रह गया? Sec beta, so hypotenuse upon adjacent, so 13 upon 12. So you can get the remaining 4 also. I hope you have understood. Sure. So this is type 1 where we found trigonometric ratios. 1.1 में we found trigonometric ratios. When you are given two sides, of a right angle triangle. Now we will find trigonometric ratios type 1.2 में, where one of the trigonometric ratio is given. Sides are not given. One of the trigonometric ratios is given. So let's see that. Okay. Alright children, still we are going to see the sum type 1. But the given conditions are different. Type 1 means what? We have to find trigonometric ratio, or we have to find the value of expressions in which trigonometric ratios are involved, or you have to prove the value of expression is equal to something. Okay. Well, still we are going to find trigonometric ratios. Now why I put type 1.2? Because your conditions are given different. In type 1.1, any two sides were given. Here, any one side and one angle are known. See, but the angle will be specifically 30 degree, 45 degree or 60 degree only. So let's see the first one. Yeah, you have to find theta. In this case, let's say P is theta given to you. In this case, say this is alpha given to you. And in this case, this is beta given to you. Okay? Be careful. I don't think this type of sums are there in the textbook, but we are going to learn each and everything, children. Okay? So that the concepts becomes very clear in your minds. Chali. Now, only one side is known. Correct? And you have to find, okay, what you have to find is cos theta and cot theta. These two you have to find. You have to find trigonometric ratios. Alright? So you need to know the measure of three sides. That is what we learned from type 1.1. If we know the measures of all three sides, we can find any of the 6 trigonometric ratios. Correct? Okay. Now, but only one side is given. But then recall, in right triangle, if the angle is of measure 30 degree, then opposite side, okay? In right triangle PQR, angle R is equal to 30 degree. Therefore, opposite side PQ is half of hypotenuse PR. This result, children, very important, remember. Okay, what is given? PQ is given. PQ is 3 is equal to half of PR. Take 3 on other side. So 3 into 2 is equal to PR. Therefore, PR is equal to 6. So I got PR 6. Now you need third side also. So find out QR using Pythagoras. Alright. So by Pythagoras theorem, we have what we have? PR square is equal to PQ square plus QR square. PR is 6 square. PQ is 3 square plus QR square. I'll continue here and then erase. So A square minus B square you can get. Therefore, 6 square minus 3 square is equal to QR square. I.e. the right hand side I am writing on left hand side, and left hand side I am going to write on right hand side. But instead of 6 square minus 3 square, 6 plus 3 into 6 minus 3. So that is 9 into 3. That is 27. Therefore, QR square is equal to 27. So taking square root on both sides. Now 27, the prime factors, 3 9s are, 3 3s are, 3 1s are. So you got one pair. So therefore, QR is equal to 3 out, and alone root mein 3 rahega. Alright. So you got this also now. This is 3 root 3. Now I am not going to write. I am just going to say. First you have to find cos theta. So by definition, cos theta is adjacent side. Okay, पहले वो मैं लिख देता हूँ. With respect to this theta, this is opposite side. Without any doubt, this is hypotenuse, and the remaining side is adjacent side. So now, by definition, cos theta is adjacent upon hypotenuse. That is 3 upon 6. So that is 1 upon 2. Cot theta is adjacent upon opposite. Therefore, 3 upon 3 root 3. 3 3 cut. So 1 upon root 3. Got it, children? Okay. Same way. Here, you have measure of angle 60 and not 30. But you can imagine, then this must be 30. ये 30 होना चाहिए. है कि नहीं? That is 30. So मतलब in right triangle DEF, angle F is equal to 60. Therefore, angle D, that is equal to 30 degree. It is alpha as well, but I am writing angle D is equal to 30 degree. Therefore, the side opposite to that, EF, is half the hypotenuse DF. This time DF is available, half of 10, and that is pi. So what is EF? This is phi. Using Pythagoras, you find out DF, and then whatever sec alpha and tan alpha. Suppose you have to find this, or you can find all 6 if you want, because you know measures of all 3 sides. Oh, by using Pythagoras you will have to find DF. I'm not finding it, or should I? Okay, let's see. By Pythagoras, we have hypotenuse square, that is DF square, is equal to DE square plus EF square. DF is 10 square, DE is pi square plus EF square. Therefore, EF square is equal to 10 square minus pi square. 10 square minus pi square. That is 10 plus pi into 10 minus pi. That is 15 into pi. That is 70 pi. So if you remove the prime factors of 75, 320 pi's are, pi's are, pi ones are. So you have got pair of pi. So pi and 3 is alone, it will remain in root. So EF square is 75. So taking square root on both sides, EF is equal to pi root 3. So this is pi root 3. Now sec alpha, that is okay. With respect to this alpha, this is opposite side, this is hypotenuse, and this is going to be the adjacent side. So sec alpha, hypotenuse upon adjacent. So 10 upon pi root 3, 2 upon root 3. Alright. So what you are getting actually, sec alpha is equal to 2 upon root 3 after cancellation. इसलिए मैं बता रहा हूं क्योंकि here you have to multiply and divide by root 3. You have to rationalize the denominator. So that is 2 root 3 upon 3. So sec alpha is 2 root 3 upon 3. Even if you live in this form 2 upon root 3, it's okay. But you should always remember, roots are not to be kept in denominators. Okay. Now next one. Alright. Children, you all have to do yourselves. आपको खुद करना होगा ये काम. Are you getting me, children? You all will have to do this work. Chaliye. Now, let's see this. Children, only one side, but this is 45. So this is also 45. So 45, 45, two angles are equal. सामने वाली side BC, इसके सामने वाली side AB. They are not known, so I'll call it XX. Now using Pythagoras, you will get the value of X. AC square, I'm writing directly. AB square plus BC square. You all please write systematically, okay? The presentation should be decent. It should be good. Attractive, right? So this is 4 root 2 whole square is equal to, this is x square plus x square. So square of 4 is 16 and square of root 2 is 2 is equal to 2x square. 2 cancel. I.e. taking square root on both sides. So 4 is equal to x. I.e. x is equal to 4. So now this is 4, this is 4, and this is 4 root 2. Find. Say suppose you have to find cosec of beta. So cosec beta is hypotenuse upon opposite. 4 root 2 upon 4 cancel. So that is root 2. And you can find any that you want. I hope you have understood. So today we have seen type 1, type 1.2 and type 1.1 and type 1.2. And in both we found trigonometric ratios when type 1.1, 2 sides of right triangle are given, and type 1.2, which you won't find in your textbooks or any reference books, that is 1.2, that one angle and one side is given. But specifically that angle has to be 30, 45 or 60. So that's all in this session. We'll meet again in the next session tomorrow. Alright. So till then, goodbye. Have a good day.